was debating whether or not to read this on stream, but I decided that I'm gonna do it because I think it's gonna help me focus. So today I'm just gonna read these three articles here, and then maybe if I have time after that, I'm gonna practice Vim and do the Italian thing. So zero knowledge rollups. Zero knowledge rollups, ZK rollups are layer 2 scaling solutions that increase throughput on Ethereum mainnet by moving computation and state storage off-chain. ZK rollups can process thousands of transactions in a batch and then only post some minimal summary data to mainnet. This summary data defines the changes that should be made to the Ethereum state and some cryptographic proof that those changes are correct. Should have read and understood the page's Ethereum scalar nature. What are zero knowledge rollups? Zero knowledge rollups, ZK rollups bundle or rollup transactions into batches that are executed off-chain. Off-chain computation reduces the amount of data that has to be posted to the blockchain. ZK rollups operators submit a summary of the changes required to represent all the transactions in the batch rather than sending each transaction individually. They also produce validity proofs to prove the correctness of their changes. The validity proof demonstrates with cryptographic certainty that the proposed changes to Ethereum state are truly the end result of executing all the transactions in the batch. The ZK rollups state is maintained by a smart contract deployed on the Ethereum network. To update this state, ZK rollup nodes must submit a validity proof for verification. As mentioned, the validity proof is a cryptographic assurance that the state change proposed by the rollup is really the result of executing the given batch of transactions. This means that ZK rollups only need to provide validity proof to finalize transactions on Ethereum instead of posting all transactions data on chain like optimistic rollups. So I wonder if anyone can send this proof and do the transactions based on how does that work? I don't understand really well. I guess anyone can send it as long as you are able to validate the proof, then the transactions are valid. But then, yeah, how does that work? Hopefully they will talk about that. Security model for certain layer 2 solutions where to increase speed, transactions are rolled up into batches and submitted to Ethereum in a single transaction. The transaction computation is done off-chain and then supplied to the main chain with a proof of their validity. This method increases the amount of transactions possible while maintaining security. Some rollups use fraud proofs. And this is the problem. Each article opens up a lot more articles. Validium, an off-chain solution that uses validity proofs to improve transaction throughput. Unlike zero-knowledge rollups, Validium data isn't stored on layer 1 mainnet. This is just fraud proof, a security model for certain layer 2 solutions where to increase speed, transactions are rolled up into batches and submitted to Ethereum in a single transaction. They are assumed valid but can be challenged if fraud is suspected. Fraud proof will then run the transaction to see if fraud took place. This method increases the amount of transactions possible while maintaining security. Yeah, but what if there are frauds? So the whole thing, all the transactions fail. Let's say one of the transactions is a fraudulent one, but the rest are valid. Then what would happen then? It just brings a lot more questions instead of answering. Type of layer 2 scaling solution that batches multiple transactions, submits them to the Ethereum mainnet chain in a single transaction. This allows for reduction in gas costs and transaction throughput. There are optimistic and zero-knowledge rollups which use different security methods to offer these scalability gains. I guess I need to study these optimistic and zero-knowledge to understand how they work I assume it's probably an algorithm or something like that that works like a hash function. Read this one. Yeah, same thing. There are no delays when moving. Oh, maybe I didn't read this one. Optimistic rollups are layer 2 protocols designed to extend the throughput of Ethereum's base layer. They reduce computation on the main Ethereum chain by processing transactions off-chain, offering significant improvements in processing speeds. Like other scaling solutions such as sidechains, optimistic rollups derive security from mainnet by publishing transactions results on-chain. Are plasma chains, which also verify transactions on Ethereum with fraud proofs but store transaction data elsewhere. As computation is the slow, expensive part of using Ethereum, optimistic rollups can offer up to 10 or 100 improvements in scalability. Optimistic rollups also write transactions to Ethereum as call data, reducing gas costs for users. An optimistic rollup is an approach to scaling Ethereum that involves moving computation and data storage off-chain. Okay. Optimistic rollups operators bundle multiple off-chain transactions together in large batches before submitting to Ethereum. This approach enables spreading fixed costs across multiple transactions in each batch, reducing fees for end users. Optimistic rollups also use compression techniques to reduce the amount of data posted on Ethereum. Optimistic rollups are considered optimistic because they assume off-chain transactions are valid and don't publish proofs of validity for transactions batches posted on-chain. This separates optimistic rollups from zero-knowledge rollups that publish cryptographic proofs of validity for off-chain transactions. They assume off-chain transactions are valid and don't publish. Also, they don't post this proof of validity, but zero knowledge does. I still don't get how it works really well. Optimistic rollups instead rely on a fraud-proofing scheme to detect cases where transactions are not calculated correctly. After a rollup batch is submitted onto Ethereum, there is a time window called a challenge period, during which anyone can challenge the results of a rollup transaction by computing a fraud proof. If the fraud proof succeeds, the rollup protocol re-executes the transaction and updates the rollup state accordingly. The other effect of a successful fraud proof is that the sequencer responsible for including the incorrectly executed transaction in a block receives a penalty. If the rollup batch remains unchallenged, all transactions are correctly executed after the challenge period elapses, it is deemed valid and accepted on Ethereum. Others can continue to build on an unconfirmed rollup block. But with a caveat, transactions results will be reversed if based on an incorrectly executed transaction published previously. Yeah, this is what I don't understand. Because if you scale the transactions a lot, then there's one fraudulent one, then it screws up all the other ones. It doesn't make a lot of sense to me. Because I'm probably missing something, because that way it would be really easy to mess this up by constantly spamming fraudulent transactions. Well, I guess you can't really do that. Yeah, that's probably because it's more centralized. So the company or the people creating the layer 2 have control over all the transactions, I guess. That's why it's different. So basically, yeah, they are responsible for validating all of them. So there is an incentive for them to mess one up on purpose. Thank you for the follow. I'm not gonna say your name because I don't. Oh, I can see here. Kiro Shift. Yeah. Before they didn't have the names on OBS, but after the updates, I can see. How do optimistic rollups interact with Ethereum? Optimistic rollups are off-chain scaling solutions built on top of it, built to operate on top of Ethereum. Each optimistic rollup is managed by a set of smart contracts deployed on the Ethereum network. Optimistic rollups process transactions of the main Ethereum chain, but post off-chain transactions in batches through an on-chain rollup contract. Like the Ethereum blockchain, the transactions record is immutable and forms the optimistic rollup chain. The architecture of an optimistic rollup comprises the following parts. On-chain contracts, the optimistic rollups operation is controlled by smart contracts running on Ethereum. This includes contracts that store rollup blocks, monitor state updates on the rollup, and track user deposits. In this sense, Ethereum serves as the base layer 1 for optimistic rollups. Off-chain virtual machine. Although contracts managing the optimistic rollup protocol run on Ethereum, the rollup protocol performs computation and state storage on another virtual machine separate from the Ethereum virtual machine. The off-chain VM is where applications live and state changes executed. It serves as the upper layer or layer 2 for an optimistic rollup. An optimistic rollup are As optimistic rollups are designed to run programs either written or compiled for the EVM, the off-chain VM incorporates many EVM design specs. Additionally, fraud proofs computed on-chain allows the Ethereum network to enforce the validity of state changes computed in the off-chain VM. Optimistic rollups are described as hybrid scaling solutions because while they exist as separate protocols, their security properties are derived from Ethereum. Among other things, Ethereum guarantees the correctness of a rollup's off-chain computation and the availability of data behind the computation. This makes optimistic rollups more secure than pure off-chain scaling protocols, e.g. sidechains that do not rely on Ethereum for security. I guess what I was saying about they control the transactions is not necessarily accurate. I don't understand the difference really well. Because I think in the case of the sidechains, they control the transactions, but on the rollups, no. And there's a lot more questions than answers, to be honest. Data availability. As mentioned, optimistic rollups post transactions data to Ethereum as call data since the rollup chain's execution is based on submitted transactions, anyone can use this information, anchored on Ethereum's base layer. Just execute the rollup's state and verify the correctness of state transitions. Data availability is critical because without access to state data, challengers cannot construct fraud proofs to dispute invalid rollup operations. With Ethereum providing data availability, the risk of rollups operators getting away with malicious acts, e.g. submitting invalid blocks, is reduced. Optimistic rollups also rely on Ethereum for censorship resistance. In an optimistic rollup, a centralized entity, the operator, is responsible for processing transactions and submitting rollup blocks to Ethereum. This has some implications. Rollup operators can censor users by going offline completely or by refusing to either produce blocks that include certain transactions in them. Yeah, that's the thing that I was talking about, so I was correct. That the trade-off is you lose the centralization. I think I saw this coming as well before because it's super obvious. You can't have something that is fully decentralized. It doesn't work. So you need some degrees of centralization, and I think that this is the evolution towards that. But I think it seems a little bit incomplete to me, or maybe it's probably because I have to understand a lot better. Rollups operator can prevent Rollup operators can prevent users from withdrawing funds deposited in the rollup contract by withholding state data necessary to Merkle proofs of ownership. Withholding state data can also conceal the rollup's state from users and prevent them from interacting with the rollup. Optimistic rollups solve this problem by forcing operators to publish data associated with state updates on Ethereum. By forcing operators to publish data. Publishing rollup data on-chain has the following benefits. If an optimistic rollup operator goes offline or stops producing transactions batches, another node can use available data to reproduce the rollup's last state and continue block production. Users can use transaction data to create Merkle proofs, proving ownership of funds and withdraw their assets from the rollup. Users can also submit their transactions on L1 instead of to the sequencer, in which case the sequencer has to include the transactions within a certain time limit to continue to produce valid blocks. Yeah, I think I have to go back to the previous one and before I continue this. Maybe I'll read this one and then go back. Another role Ethereum plays in the context of optimistic rollups is that of a settlement layer. Settlement layer anchors the entire blockchain ecosystem, establishes security, and provides objective finality if a dispute occurs on another chain. Optimistic rollups in this case that requires arbitration. Ethereum mainnet provides a hub for optimistic rollups to verify fraud proofs and resolve disputes. Moreover, transactions conducted on the rollup are only final after the rollup block is accepted on Ethereum. Once a rollup transaction is committed to the Ethereum's base layer, it cannot be rolled back, except in the highly unlikely case of a chain reorganization. So this also brings to me the question that you are not, as far as I understand now, you're not getting rid of front running, and uh, in fact, it's probably even worse because, but maybe you are because the zero knowledge proof also enforces that, but I'm not sure if that's the case. Because they're talking about the validity of the transactions, but they're not talking about the ordering of transactions in the block. But I guess it has to be congruent, probably. Yeah, but how does that work? That's another question. I think the best thing to do is gonna be to study the algorithms to understand. Because the way that the proof is created, it matters. But after watching the videos, I still don't. I get the concept, but not the specifics. And it feels like things are moving extremely fast. It's really hard to catch up to everything. Because after I'm done with this, it feels like there's gonna be 5 different things. Oh, I was gonna read this one after. So I guess I kind of read this a little bit as well. Stopped here, I think. No, it stopped there. There are no delays when moving funds from a ZK rollup to Ethereum because exit transactions are executed once the ZK rollup contract verifies the validity proof. Conversely, withdrawing funds from optimistic rollups is subject to a delay to allow anyone to challenge the exit transaction with a fraud proof. So I guess anyone can create zero. The way that it works is pretty much you create a zero knowledge proof on a smart contract, and then you can build the layer two on top of that, and that's why it's different than yeah. But then I'm not sure how the sidechain works because it might be the same mechanism. ZK rollups write transactions to Ethereum as call data. Call data is where data is included in external calls to smart contract. To smart contract functions where data is included in the external calls to smart contract functions gets stored. I think this is slightly written wrong, but whatever. Information in call data is published on the blockchain, allowing anyone to reconstruct the rollups state independently. ZK rollups use compression techniques to reduce transaction data. For example, accounts are represented by an index rather than an address, which saves 28 bytes of data. On-chain data publication is a significant cost for rollups, so data compression can reduce fees for users. How do ZK rollups interact with Ethereum? A ZK rollup chain is an off-chain protocol that operates on top of the Ethereum blockchain and is managed by on-chain Ethereum smart contracts. ZK rollups execute transactions outside of mainnet, but periodically commit off-chain transactions batches to an on-chain rollup contract. This transaction record is immutable, much like the Ethereum blockchain, and forms the ZK rollup chain. The ZK Rollups core architecture is made up of the following components. I definitely have to study the zero knowledge thing, the algorithm itself, not the explanation. Because I think the way to find this on chain is going to be to look for the function. And there's probably, there's definitely a way, it might be complicated, but a way to find different functions based on the block history with that's another thing that I have to study that I was gonna study after all of this stuff and the Uniswap stuff is how much information can I get from a node and how to get that information. I'm not really sure if I can get the functions. But I think it should be possible because functions are transactions. So yeah, it should be possible to get everything, I think. But I remember I have to see on the other project because I don't remember seeing the data from the Web3 API. Don't remember seeing data from functions. I got the data from transactions, but it's all hashes, so it might be different because the way that is stored makes you lose the ability to see if it's a function or not. Yeah, I think I have to run the full node, but then I have to study. I'm gonna study this after I'm done with all of this stuff. which is what data can I get from the by running the node and how to get the data. I think that's the only way. I don't think you can use the Web3 API to get this kind of data. That's the difference. Because the Web3 is only gonna get the block stuff. The ZK Rollups core architecture is made up of the following components: on-chain contracts. As mentioned, the ZK Rollup protocol is controlled by smart contracts running on Ethereum. This includes the main contract, which stores rollup blocks, tracks deposits, and monitors state updates. Another on-chain contract, the verify contract, verifies zero-knowledge proof submitted by block producers. Thus, Ethereum serves as the base layer or layer 1 for the ZK rollup. And I think that's something anyone can do probably. Off-chain virtual machine. While the ZK rollup protocol lives on Ethereum, transaction execution and state storage happen on a separate virtual machine dependent of the EVM. This off-chain VM is the execution environment for transactions on the ZK rollup and serves as a secondary layer or layer 2 for the ZK rollup protocol. Validity proofs verified on Ethereum mainnet guarantee the correctness of state transitions in the off-chain VM. ZK rollups are hybrid scaling solutions, off-chain protocols that operate independently but derive security from Ethereum. Specifically, the Ethereum network enforces the validity of state updates on the ZK rollup and guarantees the availability of data behind every update to the rollup's state. As a result, ZK rollups are considerably safer than pure off-chain scaling solutions, such as sidechains. In pure off-chain scaling. Yeah, I'm gonna have to read this one as well. Luckily, this one is not that big, but it looks like there's a bunch of links, so it might take a lot of time. I'll also open this twice, and I feel like I'm reading the same stuff here. Maybe it's similar. No, this one is a different one. Oh, yeah, I was here. Yeah, this one is the same as this one, I think. Yeah, okay. ZK rollups publish state data for every transaction processed off-chain to Ethereum. With this data, it is possible for individuals or businesses to reproduce the rollup state and validate the chain themselves. Ethereum makes this data available to all participants of the network as call data. ZK rollups don't need to publish much transaction data on chain because validity proofs already verify the authenticity of state transitions. Nevertheless, storing data on chain is still important because it allows permissionless, independent verification of the L2 chain's state, which in turn allows anyone to submit batches of transactions, preventing malicious operators from censoring or freezing the chain. On-chain is required for users to interact with the rollup without accessing to state data. Without access to state data, users cannot query their account balance or initiate transactions, e.g. withdrawals that rely on state information. Transaction finality. Ethereum acts as a settlement layer for ZK rollups. L2 transactions are finalized only if the L1 contract accepts the validity proof. This eliminates the risk of malicious operators corrupting the chain, e.g. stealing rollup funds, since every transaction must be approved on mainnet. Also, Ethereum guarantees that user operations cannot be reversed once finalized on L1. Censorship resistance. Most ZK rollups use a supernode, the operator, to execute transactions, produce batches, and submit blocks to L1. While this ensures efficiency, it increases the risk of censorship. Malicious ZK rollup operators can censor users by refusing to include their transactions in batches. As a security measure, SDK rollups allow users to submit transactions directly to the rollup contracts on mainnet if they think they are being censored by the operator. This allows users to force an exit from the ZK rollup to Ethereum without having to rely on the operator's permission. And this, I'm not sure if I'm understanding this stuff because I'm also really tired. Maybe it's better to read this another time. I think I'm gonna keep going, but I'm definitely not gonna be able. I thought I was gonna be able to read all three of them, but because I'm opening several different ones and I'm thinking about a bunch of other stuff, kind of very distracted right now. How do ZK rollups work? Transactions. Users in the ZK rollup sign transactions and submit to L2 operators for processing and inclusion in the next batch. In some cases, the operator is a centralized entity called a sequencer, who executes transactions, aggregates them into batches, and submits to L1. The sequencer in this system is the only entity allowed to produce L2 blocks and add rollup transactions to the ZK rollup contract. Other ZK rollups may rotate the operator role by using a proof of stake validator set. Prospective operators deposit funds in the rollup contract, with the size of each stake influencing the staker's chances of getting selected to produce the next rollup batch. The operator's stake can be slashed if they act maliciously, which incentivizes them to post valid blocks. I think I'll read more, maybe two more, and then I'll stop. It's kind of hard for me to concentrate now because I'm thinking about a bunch of different things. I was studying a bunch of other stuff before I started streaming. That's why I wasn't sure if I was gonna do this today. But I kind of wanted to finish this today, so. But now seeing that it's probably not gonna happen, I think I'm gonna stop after reading this through here. How ZK rollups publish transactions data on Ethereum. As explained, transaction data is published on Ethereum as call data. Call data is a data area in a smart contract used to pass arguments to a function and behaves similarly to memory. While call data isn't stored as part of Ethereum's state, it persists on chain as part of the Ethereum chain history logs. Call data does not affect Ethereum's state, making it a cheap way to store data on chain. The call data keyword often identifies the smart contract method being called by a transaction and holds inputs to the method in the form of an arbitrary sequence of bytes. ZK rollups use call data to publish compressed transactions data on chain. The rollup operator simply adds a new batch by calling the required function in the rollup contract and passes the compressed data as function arguments. This helps reduce costs for users since a large part of rollups fees go towards storing transaction data on chain. State commitments. I think this is the last one, then I'll stop here and probably read this tomorrow or some other day. State commitments. The ZK rollups state, which includes our true accounts and balances, is represented as Merkle tree. A cryptographic hash of the Merkle root, is stored in the on-chain contract, allowing the rollup protocol to track changes in the state of the ZK rollup. The rollup transitions to a new state after the execution of a new set of transactions. The operator who initiated the state transition is required to compute a new state root and submit to the on-chain contract. If the validity proof associated with the batch is authenticated by the verifier contract, the numerical root becomes the ZK rollups canonical state root. Besides computing state roots, the ZK rollup operator also creates a batch root, the root of a Merkle tree comprising all transactions in a batch. When a new batch is submitted, the rollup contract stores the batch root, allowing users to prove a transaction, e.g., a withdrawal request was included in the batch. Users will have to provide transaction details, the batch root, and a Merkle proof showing their inclusion path. Yeah, it's really confusing. Probably gonna have to read this again because I not being able to focus really well now. And I also think I'm gonna watch videos actually before I read this again. I'm gonna watch some videos off stream about zero knowledge proofs so I understand better. And then I think I'll start from this point again some other time. And it's not really clearing my doubts, this article. I'm just having a lot more questions. So I think I want to stop here and I'll probably be back tomorrow or some other day. So yeah, see you then.